We'll start exactly 8:35. Good evening. Good day, Mr. Jonathan. I believe you can hear me.
Yes, I can hear somewhere. Good evening.
Okay, good evening. So I said let's give like 5 more minutes for. So we'll start by 8. And we all hear me. Okay, good. We are welcome to today's DSC session. Okay, so today we'll be discussing a very interesting topic. And it will be handled by Mr. Jonathan. Without further ado, let me just allow Mr. Jonathan. It should be very practical, so we'll not be boring you with theories. So it's very practical. So just open your laptop and start coding. Okay, Mr. Jonathan.
Yeah, thank you, Samuel. Okay. So I'll be sharing my screen. I'll be using this platform. I haven't used it before, but I'll just try and see how it works. Yeah, okay. So our topic today is single linked list. So we know that in Java we have different type of data structure. We have the array, we have linked lists, and we have both single linked list and double linked list. Then we have graph, trees, and the rest of them. But linked lists, just like graph and trees and other complex data structures. So there is something peculiar about it. So a good grasp of linked lists, we make it easy for anyone to understand this other complex data structure in Java, simply because they follow similar approach. So unlike the previous ones we've been looking at, like the array that use contiguous block to store objects in the memory, which is the heap. So linked lists create individual objects, then link them through a reference or a pointer. So it's a bit different from the normal array which we are used to. So for those who are coming across linked list for the first time, more like the data structure aspect of it, because I'm sure we've used linked list and array list, which are somehow related to this. So to deal with linked lists, there is something we call node. So we are going to look into that, but yeah, I think I'll explain why writing the code I explain. So we're going to look at some of the methods of a linked list and how a single linked list, which is what we are looking at today, how it operates. So a single linked list, to be specific, is that it has only one pointer, which points to the next, references the next object, which is the next node, compared to the double linked list, which has the previous and the next object. So minute. So first of all, I would like to give some illustration and background info on what we want to do. So let's take, for instance, to work with a linked list, we need what we call a node. So a node contains a data and a reference to the next node. So in case there is no next node, that reference which points to the next node is going to be null. Okay. Let's say we have this, and let's say we have one here, then we have a pointer. So if we have another node, let's say the value, the data here is 2, and it also has a pointer pointing to the next list, and we have another one. Let's say the data it contains is 5, and it doesn't point to anything. So in this case, it is null if you're writing code. So we have 3 nodes here. So we can call this a list as well. But one thing we should know that it contains a data which can be of int or any type. It can be int, any numeric type. Then it contains a reference to the next node. So this reference is going to be of type node. So the node class is going to contain two variables, one of int and one of node. It's a node because we want it to be able to reference another type of itself. If we use any other type, in Java or in programming, to be specific, two types that are not two object or data that are of different types, you cannot assign them to each other. So to be able to connect one node to another node or one list to another list, the reference needs to be of the same type. If not, there's going to be a type mismatch. I don't know if I'm communicating. Can you guys hear me? Okay, okay.
Yes, I can
Yes.
hear you.
Definitely, sir.
Where do I keep okay. So to deal with linked list, just like I said, we need two instance variable, which is data and node. This we use to reference the next value. If it is null, that means there's no next value. So right now we have the data and the node. Then we need a constructor of this node that we use to initialize the data. So we want to be able to use this constructor of node to initialize this data. So this one will be null, except we are creating another node. Then we will have to use this to link the other node. But the only this constructor is going to accept only one parameter, which is the value of the node we are creating, the new node we want to create using this object. I think we are all used to this. We can use Lombok to do this anyway. This is supposed to be next. This time around, we need it to be null. If there is no next node, it needs to be null, except we have more than one node, then this value is going to be pointing to the next node or next list. But if there is no next list, the value is null. We want to look at three methods of a list to start with. So one of them is delete by data or by value. So let's say we have this specific example. Let's say we want to delete this particular node here. So we are going to search till we get where the value is to. So we delete this. So that's what I mean. Okay, so how do we delete an element in a single linked list? So let's say we want to delete this particular element in this single linked list. So what we do is we move this pointer, instead of this pointer pointing to this, we move it to this one. So if we move this from here to here, so this particular value, there's nothing pointing to it again. So the garbage collector, we collect this value because it's now ready to be garbage collected. That is how Java works. So if there is no object referencing, if an object is no longer being referenced, it is ready for garbage collection. But there's a caveat to this. If this was to be a double linked list, if we move the pointer of this value to this, we can also delete this using the previous of this one. What did I do? Yeah, using the previous of this one, which is pointing to this. But since we are dealing with single linked list, we don't need to worry about this. Once we move the pointer from this to the other value, the garbage collector will handle this. So if we want to print out this list, the only thing we'll be able to print is this and this. There's no longer reference to this, so this is out. If we want to delete 4 from the original list we have, if we want to delete this, for example, what we have to do is to iterate starting from the head to this point. If we meet, so deletion in a linked list, you need to search by value. Maybe you call it a key or anything. So the delete method will accept the key which you want to use to search for which of the list you want to delete. Because you need to know what you want to delete. A linked list doesn't make use of index like an array. So you need to search by the value that list contains to be able to know which one you want to delete. So if this is what we want to delete, so There's also a caveat to this one. If you want to delete the last element, you need to use, you don't need to get to the last element to delete that element. You need to be in this place, then use the reference of this value. I think when we write the code, we'll get to see it better. So let me do the implementation of adding an element to the head. We need to create the class linked list itself to be able to create its method. So to create a linked list, we are going to make use of the node class. So the node is the list in this case. So we can decide to rename this node as a list. And the linking is going to be done using this reference of the node. Please, if you have any question, you can ask. As I cannot see the chat. Yeah, thank you. And then also there's something I did not make mention of. Yeah, in a linked list, we have what we call the head and the tail. So in this case, this is the head and this is the tail. So the first list is the head, while the tail is the last one. So if we want to add an element to the head, what we want to do specifically is to make the value we are adding to be the first value in the list, in the linked list. And if you're adding to the tail, we want the new value we are adding to be the last value in the linked list. We need to accept the value we want to add to the linked list. So this is where it gets tricky. So to add an element to a linked list, we need to create a node, then add that value to it. So originally, this linked list only have a node that is pointing, it is not pointing to anything. So the next, it is pointing to null at this point. So we only have a reference of a node. There is no value. At this point, this is the only thing we have here. We have a reference that is pointing to null. Hello, can you guys hear me?
Yes.
Okay. So yeah, I want to ask a question. Yeah. So you can put the answer on the chat. Let me see. So what is the difference between I'm coming. Because if we don't do this, we are going to have problem later on understanding what I'm doing. I'm coming. Let me create this an object. And my question is, what is the difference between this and this? We have, okay. The way it is represented in memory. I can put your you can put your answer in the comments in the chat.
So the question again, I did not get the question. I think your screen was not moving.
Okay, the difference between line 15 and line 18. Line 15, this and this. I can also put it in the chat if we don't get it. Okay, yeah, you are right, Samuel. So it's a declaration and then assignment. So this line 1, we have a node reference. It does not contain any value. While in line 2, we are creating a node with a value and a reference to it, which is new node. So in this case, if we want to create a new node, we need to make reference to this head, because the way linked lists work is you are creating individual objects in memory, but you want to link them together. Each time you create a linked list, you are creating a new object, but you're looking for a way to link them together. That is what makes it a linked list. Unlike an array, this is the way an array works. An array, everything is, all the values are stored together. Let's say we have 2, 4, we want to add 7. Each time you are modifying this, adding or removing value from this, it is dealing with this contiguous block. But a linked list, each time you are manipulating a linked list, if you are adding new value to a linked list, you are creating a new object. They exist in different locations in the memory, but using the pointer, you link them together. So if I link this to this and this to this, then this to this, if I want to print the value, I need to start from the head, which is the first value. I iterate from here to here to here to here. When I meet null, I stop, then print out the whole value. The way it works is different from the way an ordinary array works. Yeah, so back to what I'm doing. So to create a linked list, to add an element to the head of a linked list, we need to create that node add data to it, then change the pointer of the head. Originally, from what I illustrated here, this is what we have inside this code. This head is pointing to null here from this implementation here. Next is not pointing to anything. So if we want to add a value to this, if we want to add new value or new node, we want to create, we want to add a new node. Let's say the value is 2. This is head. Pardon my writing. This is head. So instead of pointing to null, we want head to point to this new node we created. And the next of this new node we created, we want it to now point to null. What this particular line is doing is we want the new node we are creating to point to whatever head was pointing to before. Like I said before, head is not a node. It is just a reference to a node. And in this case, in the implementation we are doing, originally there was nothing existing. We only have this reference of a node, which is not pointing to anything. Now we want to add a new list or a new node with value 2. So we want head, we want to move the pointer of head from null to this. So to do that, this single line of code will help us to do it. So the new node, the pointer of node is pointing to head. And we want the new node is pointing to what head was pointing to before, which is null. Now we want head to point to the new node. You can ask question if you have anything to ask. If you have any question on the implementation of adding value to head or adding node to head, you can ask. It looks confusing sometimes, but yeah, with time we'll get it.
Yeah. Although my question is more on like, hello, can you hear me?
Yes, I can hear you, Samuel. Go ahead.
Yeah, because this particular linked list has been like there's a particular algorithm I was solving on, and the solution to it requires a linked list. Yeah, so but it's not I didn't mean it's a single loop, like you are just looping and inserting, it would have been easier, but it's like you are branching out for every node, like for every point you get in the node, you are branching out to two other points. And from every point you get in that node also, you are branching out to two other points. Yeah, so how do you, my question, Sha, is how do you look through such? You get, but I don't think
Okay.
we've got to.
Your question might be related to a binary tree, but if it is a linked list, then it's a double linked list. If this was to be a double linked list, then we are going to have another node here called previous. So the way a double linked list works is this. So instead of having only let's say the value is 3. So instead of having a pointer pointing only to the next value, we have one that is also pointing to the back. So you can check the previous, and the next. So, but single linked list only moves forward. The pointer is pointing to the next value ahead of it, not the one behind it. I don't know if that answers your question, Sam.
Yeah, I think it does. I think I would consider both the bidirectional and the binary search. Or I feel that particular problem is still giving me headache. Maybe I'll reach out to you.
Yeah, I
Clarify.
think the idea behind all of them is the use of node, both linked list, graph, tree. So they all use node. And the way to iterate all of them is if you can get hold of the head, which is the first value, then you can use that current value, which is maybe head or current or anything you decide to call that node, dot next, which is this. If you call the reference of this node dot next, that means you are at this point. Then if you reassign current dot next, you are in this location now. You'll be able to access the value here. So that is how you do the iteration. It's not straightforward as an array. So it's a bit tricky. So so this is how to add element to the head. So let me draw a diagram of it to illustrate it better. So initially we only have a reference of head. This is head. This is head. It was pointing to null. And we created a new node, let's say 2. So if you want to add this value to what we have already, what we do is to make node this first value, because we want to add it to the head. This node, which is the head, is the first, but we want to make this incoming one to be the head. So what we are going to do is move the pointer of this incoming one to point to head, which is what we are doing here. New node dot next is equals to head. So whatever head was pointing to, which is null, we want new node to point to that. Then the head should now be pointing to new node. If you guys have any question, you can ask. I think that will make me to be able to understand it, explain it better. But if you don't have any question, we can go to the next method of a single linked list. I think we might need to have more than one session for this particular data structure. Do you guys have any question, or should I go to the next one?
No question for me.
Okay, so let's do that for adding a detail. Or should we display, should I do an example to show how this works? Let me write the display method.
Yeah, I think that would be better.
Yeah. Remember, in our linked list, we are making reference to this node, which is the pointer that we are using to connect to other subsequent node or list we are creating. So if we want to iterate, we are going to start from the head. Without the head, we will not be able to access other linked lists, other lists in the linked list. So we are going to start from the head. So we use a while loop. There are cases where you can use recursion to do this, but while loop is easier to go by because it's straightforward. So we want to do something to display the values in a linked list. The first thing we want to do is to know if the head is not null, we continue the loop. But if the head is null, that means it contains nothing. So the first condition we check is if the head is not null. The current is the head now. So how do we get the value? If it is not null, how do we get the value in it? Going from here. Yeah, let's say I have 2 here and I have 3 here. How do I get the value here? How do I get these 2?
Reference of the next reference to choose reference.
So if we do that particular node dot value, we will get the value there, or dot data, depending on the name we give to the instance variable that stores the data. So in this case, what we used was we use data. So if we do current dot data, it will give us the value at this point. So remember, we want to print every value in each of the node in the linked list. We want to display it. Print lane will not work because print lane will give us, we print it in new lines. So we want all of them to be in the same line, like in a straight line, separated by this. So while current is not null, we want to print current.data. But if there is still another list, so we want to reassign. So let's say we are at this point. So this is node. So created an object of this and using the variable reference, we're able to access this. So we are in a while loop, while node.data. So to move from this one to this, our new current, which is to move from the first node to the next node, our current, we are going to initialize our current to the next value, which is going to be current is equals to current.next. So as long as there is a new node ahead, this will keep reassigning this value. So the first time we are at the head, we check, is the head null? If it is not null, we print the value there. Then reassign from the head now to the next value, which is this. From the head, if we are at this point, if we want to get this, we use the reference, which is this arrow, and we denoted it as next. So to get this value, we do this dot next to get us this. So to initialize our current to not be at this point. So if during the next iteration, the value is going to be our current dot data is going to be 3, because we reinitialize our current from this first node to the second node. We've moved from this to this. So the next time it will move from the new current will now be current.next, which is this one. So at this point, we want to counterfeit a situation whereby current.next is null. So what happens if this is while current is not null, we do this. What if it is null? What do we want to do? So without null in that case. So if we call this so if we create a linked list, so we should I hope you guys understand why it took the reverse order. Hello?
Yeah, we are with you, sir.
So it took the reverse order because we are adding at the head. So each new incoming node is going to take the first position. That is why 7 came before 2 in this case. Yeah, okay, so let me do the implementation for adding at the tail. This what is it called? This linked list. When I was learning it, I think that was around ending of 2021 or 2022 when we were in Decagon. It gave me a lot of problems. So if this is your first time learning it, don't bother yourself too much. Data structure sometimes it's more like mathematics, so you need to stretch your brain. So, public void. You want to insert a value at the end instead of the start. So just like we did here, each time we are operating on a node, creating a new node, we are creating a new object. Each node is a separate object stored in the heap. And we use the reference to be able to get hold of that object. So there are considerations to look into if you want to add element at the end, or a list or node at the end. So let's assume we only have the head, which is the pointer, that does not contain a value. Like there's no already exist. The value we want to add is the first value in the list. Let me just say it that way. So we need to check that. So if it is the first value, we don't need to iterate till the end of the linked list. That means we carry out the same operation like adding an element to the head. So if head is equal to null, we just add the value. We change the pointer to point to the new node, the new linked list. So the pointer of head should point to the new return. But if it is not null, then we need to get hold of the head and iterate till we get to the last value. Then we add the value at that point. And to get hold of the head, we can only use a node. We can only use a node reference to get hold of the head. So let's call this current. is equals to head. We want to iterate starting from the head to the last value in the linked list. Then we add this new value at that point. But if there's no value in the linked list, we just add it, we just make head, which is originally pointing to null, to point to this new new list or new node we just created. That's the flow. So we want to iterate the node starting from the head. So if we want to move from one node to another, just like I said before, we use the pointer, which is this next. While the next is not null, that means it contains a value. Please, if you have question, you can ask. Or should I continue? You can thumbs up, so I'll proceed. Okay. So we are iterating. The purpose of this iteration is, let me show that illustration I'm using. Okay, let's say we have this. We have this 1, 2, 3. So we have a linked list with 3 nodes, and we want to add an element at the tail, which is around this place. So we want to iterate starting from the head till we get to this point. Then we add till we get to this point. Then we add the value. So how do we know we've gotten to the last value in the list? We know that by when the next is pointing to null, which is the reference. When it is pointing to null, that means there's no value here. So we can now make that reference that is pointing to null to point to the new value we are inserting in the linked list. So that is what this section will do for us. Why it is not null, we continue. But if it is null, then we want the current of that particular node where we are. We want the pointer of that particular node where we are to point to the new value we want to add. The new node we want to add. So this is how to add element to the end. If there is no node existing, we add it to the head. If there are nodes existing, that is the current is not null, then we iterate till current is null. If current is null, we come out of this loop and do this and reassign the pointer from the current, which is now null, to the new node. We want the pointer of the last element, which is pointing to null, to now point to the new element we want to add. So if I call linked list, if I call list dot add to the insert at end, and let me say, okay, let me say 9. If I display this, So 9 is going to be at the end. Yeah. So let's say we don't have anything, this 2 does not exist. But you now add it to the head directly. I think we can continue the other implementations in our subsequent class. If you have questions, you can ask. Hello, Samuel. Hello.
Okay. Yeah. Thank you so much, Sir Jonathan. Thank you. Really appreciate it. Is there any question? No question. Is this strange to you? No one is answering. If you know I don't have a question, Balogu.
It's usually strange the first time. Yeah, it's something is more like mental gymnastic. You need time to grasp the whole thing. So I understand.
Okay. All right. So if there's no other question, thank you so much for joining the section. Really appreciate your time. Do enjoy the rest of your night. Good night, everyone. Thank you for joining.